Ladies and gentlemen, welcome to this lecture on charging electric vehicles from sustainable energy sources. I'm Gautam Ram, I'm an assistant professor at the Delft University of Technology. In this video, we will talk about what is well-to-wheel emissions of electric vehicles. Next, we will talk about how we can charge electric vehicles from renewable source of electricity. And finally, we will look at how we can combine solar and wind energy for charging electric vehicles. If you think of electric vehicles, the first thing that comes to our mind is that it does not have any harmful tailpipe emissions. At the same time, we must take one step back and consider the bigger picture of the energy system. Most of our electricity continues to be produced from fossil fuels like coal and natural gas. This means that the use of electric vehicles results in indirect emissions at the electricity power plant. So the question is, how can we make electric vehicles truly sustainable? As per the Alternative Fuel Data Center, well-to-wheel emissions of a vehicle include all emissions related to fuel production, processing, distribution, and use in the vehicle. In case of gasoline vehicles, the well-to-wheel emissions includes all emissions from producing and extracting gasoline, refining it, distributing it to the fuel stations, and finally burning it in the vehicles for propulsion. While for electric vehicles, the well-to-wheel emissions is the emissions from the production of the fuel and its use in the power plant for producing electricity, then transporting the electricity and charging the electric vehicle battery, and finally using it in the electric vehicle for transportation. To give you some numbers, this table shows a greenhouse gas emission intensity of power generations on the y-axis in terms of grams of CO2 equivalent per kilowatt hour of electricity produced from various EU countries, which is shown in the x-axis. It has a very wide range, going from 751 grams of CO2 equivalent per kilowatt hour in Poland due to a large fuel mix dependent on fossil fuels, to Iceland, which is on the left side with 0 grams of carbon dioxide equivalent per kilowatt hour of electricity, because nearly all of the electricity in Iceland comes from hydro and geothermal energy with no emissions. So as you might have guessed, I'm a big fan of Iceland, as I've ensured that both the electricity system and therefore the electric mobility are completely emission-free. With a simple rule of thumb for electric cars of 1 kilowatt hour will give you 5 kilometers of range, the grams of CO2 emissions from kilowatt hour of electricity that you see in this graph can be easily translated to grams of carbon dioxide emissions per kilometer of vehicle driven. To see this from a different perspective, let's look at the well-to-wheel greenhouse gas emissions of electric cars from various EU countries depending on their energy mix for electricity production, and compare that to a gasoline and diesel powered vehicle shown in the two lines. You see that predominantly electric vehicles consistently outperform fossil fuel powered vehicles in terms of well-to-wheel emissions. There are, of course, exceptions in countries where fossil fuels primarily power the grid. This does not mean that we should not use electric vehicles in those countries. What we must infer is that we must not only adapt and change to electric vehicles, but also change our source of electricity from fossil fuel based to renewable energy based electricity, so that the overall emissions coming from electricity and electric vehicles are down to zero. So how can we make our electric vehicles truly sustainable? One option is to charge electric vehicles from solar photovoltaic panels. The benefits of these are numerous. First, you get zero net emissions as the electricity for charging comes from a sustainable source. Second, both electric vehicles and photovoltaic panels produce direct current or DC electricity. This opens up the possibility to directly exchange power without converting to alternating current or AC. Third, we can use electric vehicle batteries as a storage for the variable PV generation with vehicle-to-grid technology. Also, this setup simultaneously reduces the combined grid impact of electric vehicle charging and distributed solar generation by using them mutually as supply and demand to solve the problems of each other. And fifth, proximity. Solar PV can be installed on the vehicle itself or on top of parking lots nearby in the buildings, very close to where the electric vehicle and charging demand is. This makes it ideal for solar charging at workplace during the day. But what is the main challenge with using solar for charging electric vehicles? The key challenge is variability in generation. The graph shows the daily energy yield in kilowatt hours of a 10 kilowatt photovoltaic system installed in the Netherlands. As you can see in this inverted U-shaped plot, there's a significant variation of the energy produced throughout the year, showing a range from as low as 1 kilowatt hour on the least sunny winter day to 75 kilowatt hour on the most sunniest summer day. With this PV system, if you want to charge a 24 kilowatt hour electric vehicle battery every day, you can charge about half the car battery or 10 kilowatt hours per day during the winter, a little over a full EV battery or 30 kilowatt hours per day during spring, and 2 full car batteries or about 50 kilowatt hours per day during summer. The same variability is a challenge if you use wind generation for charging electric vehicles as well. Looking at the graph shown for per unit wind power generation in the Netherlands over a year, we see a U-shaped pattern that signifies more wind production in winter and less during summer. This is exactly opposite to the inverted U trend that we saw earlier for solar photovoltaics. Now, the interesting part is, what if we combine solar and wind together? By combining wind and solar in various proportions ranging from 100% wind system on the left to 100% solar system on the right as shown, we see that you always have an optimal combination of solar and wind that results in the least fraction of renewable energy which is lost or that needs to be stored for a given load profile. So the future is not wind or solar, but is wind and solar to sustainably charge electric vehicles. So let's recap. In this lecture, we understood what the well-to-wheel emissions of electric vehicles are and how the emissions from electricity production have a strong correlation to the emissions of electric vehicles. We then saw the benefits and challenges of electric vehicles from solar energy, like being direct current, electric vehicle being used as energy storage, the proximity between the vehicle and solar PV, and the variability in the generation. We finally looked at how an optimal combination of wind and solar generation is best suited to manage the seasonal and diurnal variation in energy production. Thank you for listening.